So this is the next part of the ECG Explained website. This is the QRS Complex, possibly one of the most characteristic parts of the ECG. And as we know, the QRS Complex is representing ventricular depolarization. So what I've got here is slices of the heart as if you've just chopped off the two atria. We're just focusing on the ventricles now. Because remember, the P wave talked about going through atrial depolarization. Now we're going to go through ventricular depolarization. So this is a worksheet. Hopefully you're familiar with it now. There's a link on the website as how to use this worksheet. With help, I explain it by going through this first column, how to create the vector and how to use the vector to create the ECG trace. So give that a look before you try and have a go at this with me now. So let's get straight to it. So we talk initially about the electrical propagation leaving the AV node going down the bundle as well. It starts to depolarize that left-hand side of the ventricular septum slightly before it depolarizes the right-hand side of the ventricular septum, which means what I've done is I've colored in the left-hand side of the ventricular septum. So how do we make a vector from that? Well, the vector, as we remember, goes from the depolarized myocardium to the non-depolarized myocardium. So that first vector is very small and it goes in that direction towards the non-depolarized part of the septum. So if you pause the video now and give it a go, all you've got to do is move this vector, copy and paste it to the center of this and see which direction it goes in, and see whether it goes to the positive end of leads 1, 2 and 3, and how far across the positive or negative ends of leads 1, 2 and 3 it goes, and then plot that on this graph here. So pause the video now and give that a go. Okay, so hopefully you've had a go. When I did it, I just copied and pasted it straight down. I can see that went to the actually went to the negative part of lead 1, 1 unit across. It went to the positive part of lead 2, and it went 1 unit across, and it went to the positive part of lead 3, and that went 2 units across. If your vector looks slightly different, you get slightly different values, don't worry too much. It's just as long as you use the same units throughout all of this worksheet, then it's going to be okay. So all you've got to do is just plot that on here. So we saw that lead 1 went to 1 unit in the negative end, so I've just shown that here. Lead 2 went to the positive unit up, and lead 3 went to 2 units up. So as you can imagine, as the electrical propagation moves down the septum, it depolarizes all those cells within the ventricular septum. And we know all the cells are interconnected by intercalated discs and gap junctions. So it flows very quickly through this point. Very quickly, all of the septum is depolarized, creating a vector that looks like this. It's pointing towards this non-depolarized part of the heart. So again, pause the video, copy and paste this vector into here, and then plot the values on here. Remembering to move everything from here across, because this has already been recorded by the ECG machine at this point. So we've already moved down on lead 1, and then let's see how far up it goes on lead 1 after this. So give it a go now. So this is the value that I got. So I moved this vector down. I saw that it went to the positive end of lead 1, and I measured that it went 2 units across. I saw it went to the positive end of lead 2, and it went 3 units across. And I saw that it went to the positive end of lead 3, 1 unit across. So I just moved everything from here across and then saw what happened. So it went from -1 all the way up to +2. It went from 1 to +3, and it went from +2 down to +1. So next it starts to depolarize more of the myocardium. It starts to fill up most of the apex, depolarizing the right-hand side of the heart quicker than it can depolarize the left-hand side of the heart, because we know the left ventricle is much thicker. So we can see that here, and it's starting to, it takes a little bit more time to depolarize this thicker bit of muscle here. So when you create this vector, it's still going in this downwards direction, but it is now slightly more angled up to represent that it's moving to the left-hand side a bit more. So pause the video here, and see what that vector does here and the values that occur here. Okay, so this is what I got. I copy and pasted this vector across and tried to see what happened to leads 1, 2 and 3. So lead 1 went to the positive end of lead 1, 3 units across. I saw that it went to the positive end of lead 2. It went sort of 3.5 units across. And I actually found it really tricky to work out whether it went to the positive or negative end of lead 3, because it's kind of bang in the middle of this line, pointing perpendicular to the negative and the positive end of lead 3. I'm saying it went just about to the positive end, but really it was very central, so it was almost on the 0 line again. So let's see what that did to the ECG trace. We went from -1 to +2 to +3. We went from +1 to +2 to then, -1 to +3, then to +3.5, so it's slightly curving off at the top of lead 2 there. Lead 3 went from 2 down to 1 and now back down to nearly 0, so it's already starting to go down for the QRS in the lead 3. Now we're depolarizing much more of the heart. The right hand side of the heart is all depolarized. There is just a tiny bit of the left hand side of the left ventricle that needs to be depolarized, and because it's so thick it takes that a little bit longer. So to draw a vector, I'm going to point it towards that non-depolarized, so it looks in that direction. So pause the video here and see what that does to the ECG trace. Okay, so this is what I got from that. So I just copy and pasted the vector, saw how far across leads 1, 2 and 3. I saw that it went to the positive end of lead 1 and it was kind of just less than 1 unit across. I saw it went to the negative end of lead 2 and again it was almost 1 unit across on the negative side, and to lead 3 it went to the negative side and about 2 units across. So moving everything from here to here and then adding what we found, we've got this one, lead 1, is positive, but it's just below the 1 unit line. Lead 2 is negative and just below the negative 1 unit line. And lead 3, I noticed that it went to -2, so it's already gone quite down for an S wave in lead 3 there. So this last one, there's not really much to tell. The whole heart is depolarized at this point, which means there's no vector because everything looks the same, which means there's no arrow to put in here, which means everything just goes down to the 0 line. So you can see here we've made a Q and an R wave in lead 1, we've made an R and an S wave in lead 2, and we've made an R and an S wave in lead 3. The classic QRS wave doesn't happen in every single lead, it depends what angle of the heart you're looking at. So this is how the worksheet works. Hopefully you're able to follow it and fill it out yourself. And move on to the T wave explanation once you've understood how this works.